Yeah, I don't think we're missing anybody, but I'm just going to record because Eli said, sure, do it. So 3, 2. Okay, in the last section, we had measures of center, right? Center, things that I can use to describe like the center of the data, right? Is the mean. The mean better be like the center number, right? Like the mean, the average is a way of talking about the center, right? Another way of talking about the central value is the median. Median is exactly the center number, right? Median, okay? But then we have something called the mid-range. And the mid-range was what the median should be, right? Not what the middle number actually is in my data set, but what the middle number should be. So if I had like a number that was a 10 and I had a number that was a 90, right? 10 and 90, if I add those together is 100, so my middle should be about 50, right? Okay? That doesn't necessarily mean it will be. That doesn't mean I have a number that is 50 that is in the middle, right? That would be the median, but the mid-range is what that middle should be. And then we have another thing that talks about mode. How is mode the center? Like, how does mode describe the center? If we have a bell curve, think of this as bell curve, your frequencies should be the highest in the middle, right? And the highest frequency is your mode, right? So, along those lines, the mode should be the one that occurs the most. It should have the highest frequency, and the highest frequencies, if it is a normal distribution, happen in your middle data or your center data. Does that make sense? Okay. So those are all ways of describing center. Now we're going to talk about variation. And variation is like a concept that we talk about from here on out. Like we're talking about ways that data vary. Okay. And variation, they lump range into variation, because variation is how your data is spread apart, like how spread apart your data is. So range goes in there. Also that goes in variation is the variance, which I don't really like variance a whole lot. But then we have standard deviation. Holy cow, will we deal with standard deviation? A ton. No. Standard deviation, okay? We will, I think in this section, like actually compute standard deviation. And it's like not a whole lot of fun. Okay, but then after that, I will show you how to do it on a Google Sheet, or I will show you how to do it on your calculator. I think you can do it on like even the dumb, like hold your calculator, not a dumb calculator, but like I call them like the non-graphing calculators. You can even do standard deviations on those, and I'll show you how to do that. Okay, so standard deviation is going to show you how your data deviates. Okay, all right, here we go. Variation. Let's talk about this little chart right here, okay? All right. Companies use variation, and they try to control variation because of this reason. All right, are you ready? We have a bank, and in this bank, or like say like in, well, I'm not going to use Walmart because everybody hates Walmart, right? Let's go to a bank. Let's say we're in a bank, right? If I have one line open at that bank, okay? If I have one line open at that bank, and every single time there is one line open at that bank, right? I can walk in there, and I pretty well know that it's going to take me about 20 minutes to get through the line, right? Okay? If there's only one line open at the bank, I know that when I walk in, it's going to take me quite a bit of time, like to get to the front of the line at the bank. Versus if there's multiple lines at the bank, I could get lucky and I could walk in and I could say my wait time for the bank is 80 seconds, which is like a little over a minute. Or I could be waiting like a really long time, right? Multiple lines in the bank means I could get in there and I could wait not very much, or I could get in there and I have to wait like a half hour to be seen, right? Like whatever, okay? And you know what pisses people off more? Not knowing. Like if I go in and I wait 2 minutes at the bank and I get in and out in 2 minutes, the next time I go in, I'm going to anticipate that it's going to take me 2 minutes. And the next time it's probably going to take me a half hour. And I'm going to be pissed, right? Versus if I know going in, it's going to take me 20 minutes every single time, even though sometimes it takes 5 minutes if there's multiple open. If I know and I have that consistency there, you're going to have less pissed off customers if you have that open, even though it's taking 20 minutes every single time. Here I could end up getting lucky and getting 2 minutes, right? But the consistency has better quality is what they say, okay? So like over here, an important goal of business industry is to improve quality by reducing variation, right? I know that it's going to take me a long time to go through there, so I'm anticipating that. And then I'm not going to be disappointed when it takes me that long, right? Okay? Versus if I go in thinking this, I'm going to hope that it's going to be 2 minutes and I'm going to be really pissed off if it's 30, right? They want the consistency. Does that make sense? Okay? That's what businesses try to do. They try to reduce variation to not have as pissed off of customers. That's a thing. Okay, there you go. All right. So, when we're talking about variation, things that describe variation is like standard deviation. We will discuss standard deviation like at huge length in here, okay? So let's talk about what standard deviation does, by the way. And I always describe it like this to like my algebra kids. So we'll start off here, okay? Let's say that I have an average. Let's say I have 2 classes that are taking a test. And the average for one class is an 80, right? And the average for the second class is an 80, okay? Do you remember the other day that we use X bar to represent average? Okay, get used to saying that symbol. X bar is the average. The X bar is the mean, okay? And then standard deviation was represented with an S, okay? Let's say here the standard deviation is 5, but let's say here the standard deviation is 10. Okay, all right? So on paper, if I just look at the average, it looks to me like those classes are like exactly the same, right? They both averaged 80 and they're scoring exactly the same. Except if I look on a number line here, 80 is the number that lives in the middle. In fact, if I make a bell curve out of this, right? 80 is the number that lives in the middle. And if my standard deviation is 5, 5 on this side of 80 is 75. And 5 on this side of 80 is 85, right? Okay? And we're going to learn a rule called the empirical rule. I think we did this in Algebra 2, maybe. Did we talk about the empirical rule in the bell curve chart thing? 67% of your data, if it's normally distributed, 67% of your data lives within one standard deviation. 67% is a majority, right? So I could say the majority of my people scored between a 75 and an 85. Okay. Versus here, if the average is 80, right? I'm about my bell curve here. 10 on this side would be a 70, and 10 on this side would be a 90, right? 67%, or the majority of my students scored between a 70 and a 90, right? Now, in the bottom one, I did have students that scored 90, and nobody scored a 90 in that top one, but you know which one I like better? The top one. Because it's really frustrating for me as a teacher when somebody gets 100% and somebody gets a 20%. And I'm like, what the heck did I do? Because they're sitting right next to each other. They literally heard the same lecture from me. Why is one scoring a 20 and one scoring 100? I like consistency. I like this to happen, right? I mean, like, within reason. I would like to have some people score high, right? Like, but I would rather them be consistently high kind of thing, right? Okay? Whatever. So consistency is good. That way we're all kind of on the same page. And then if we do end up being consistently bad, then I can fix it as a whole, right? Okay. Instead of some people at 100% ready to move on to the next thing, some people at 20%. Now I've got to get them caught up type of thing, whatever, right? Okay. So variation talks about how much your data varies. Okay. Now we haven't talked about range yet. Okay. If your standard deviation is higher, a higher standard deviation does what to your range? Does range go up as standard deviation goes up? Yes. The bigger the standard deviation, the bigger the range is. You're right, Jose. Okay. So the more it's deviating, have you heard that word before? Deviating from the average, right? Deviating means adding and subtracting from the average. The more it's deviating, the bigger your range is, right? Okay, the smaller the deviation, the smaller the range. Right? Yeah. Good? Make sense? Okay. Good? Beautiful. All right, let's talk about range. Range. The range uses only the maximum and minimum values. So it is very sensitive to extreme values. If I have a 90 and a 92 and a 95, if I have those 3 grades in my grade book, my range is only 5, right? But let's say I throw a 0 in there. Now what's my range? Look at how that changes it from 5 as a range to 95. Resistant or not resistant? It's not resistant to the an extreme value. It changes a lot, right? Resistant means it stands its ground. It's resisting. It's not changing. This is not resistant because it is changing a lot. Not resistant, okay? All right, because the range uses only the maximum and minimum values, it does not take every number into consideration, right? Like I don't care what the middle numbers are. I only care about the high and the low to find the range. Got it? So, in other words, I don't have to necessarily have my data set in order to find the middle, like the high and low number, right? Okay, you wouldn't necessarily have to have them in order to find the range. Got it? Okay, example 1, range. What's my biggest number? 55.6. My smallest number? 14.1.
We already had these numbers somewhere.
Yeah, we did. Yeah. In the last section, they use the same data over and over again. So that means 55.6 minus 14.1 gives me a range of 41.5. Is that true?
41.5.
Yeah. Okay, cool. Oh, man. Standard deviation. Calculating standard deviation using the longhand method.
No.
That's going to happen
Don't want to.
right now. Okay. All right. Here we go. Standard deviation. I've already talked about this, but it says a measure of how much the data values deviate away from the mean or away from the average. How much are we deviating? A bigger standard deviation means that we have really spread apart data. A smaller standard deviation means all of our numbers are really consistent together, right? Okay. Now, what's considered a big number or big deviation? What's considered a small deviation? It depends on what your data is. Yeah. Very good. Yeah. Okay. So let's say my numbers are, don't write this down. When I say it depends, don't write this down. Let's say my numbers are like 10 and 40 and 90 and blah, 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 blah. Let's say my standard deviation there is 10 versus my numbers are 1200 and 1350 and 1700, right? And my standard deviation there is 10. That's deviating more than 10. But anyway, which standard deviation is more impactful? The top one. This is making a huge difference because my numbers are smaller. Does that make sense? This one is not deviating a whole lot, even though they're both 10, right? If I have huge numbers and 10 for a deviation, that's not deviating a lot because the numbers are already huge. Does that make sense?
So when you're doing this, are you taking from every number?
Yes. When you calculate standard deviation, you're looking at every number. Yes. We'll talk about how to calculate. We're going to do calculations for standard deviation here in a second.
So technically, you have to do something for each one and calculate everyone and give it to one thing in the end.
Yes. One thing in the end. Yep.
Yes, one thing in the end. No one.
Like it will have one, the whole data set will have one standard deviation. It will have one number for the standard deviation of how it deviates.
But we're having, in the first example, we had 8, and now we have 7.
In the first example, you had what?
You showed us 80. Oh, this is the average, so we're taking the average.
Yeah, the average. Yeah. So we gotta incorporate the average in there. Yeah. Okay. All right. So here we go. Standard deviation. Let's talk about properties of standard deviation before we actually do some standard deviations. There are 2 longhand ways of calculating standard deviation. This one is this. This one is this. Which one looks uglier?
The second one.
The second one. Do you know which one's actually nicer?
The second one.
The second one. Okay. It's actually not as bad. The symbols are ugly, but it's not as bad. Okay, so here we go. Let's talk about properties and then we'll do them. The standard deviation is a measure of how much the values deviate away from the mean. Underline that. Deviate away from the mean. The value of the standard deviation is Circle this. Never negative. Your standard deviation is never a negative value. You can have your standard deviation be 0. What does that mean?
None. All of them.
It's not deviating. So you have like 90, 90. You have all 90s in your power school. That would have a standard deviation of 0 because it's not deviating at all, right? Your average would be 90, no deviation, okay? Larger values indicate greater amounts of variation. Larger values, greater variation, okay? The standard deviation can increase dramatically with one or more outliers. Standard deviation goes up or down with outliers. Actually, it goes up. Your standard deviation will only go up with an outlier. Right? Your standard deviation will increase greatly if you have an outlier. Shh. Units of standard deviation, such as minutes, feet, pounds, are the same as the units of the original data values. So if I'm talking about distance and I'm doing it in feet, your standard deviation is that many feet. It's the same units as what the original units are. Okay? So your same units. Okay? And then we'll talk about the last bullet point when I talked about a biased estimator. We'll talk about that later. Okay? Okay, good? Let's do some standard deviation. Here we go. Okay, they are going to, on example 2 and example 3, they're going to have us calculate the standard deviation 2 different ways. And I need the formulas. So write this down. S equals.
I'll read it off.
I got it.
She has it in her brain.
Okay. No, I don't. I don't have them all in my brain. I do after I do it a couple times, but I don't have this memorized. All right, here we go. They don't have the formulas there. Write the formula down. Right up to the side. And I'll explain what these things are here in just a minute. Woo. Okay, write that formula down. That's the first formula. And then if you want to write the second formula down, there it is.
Can you explain what that says?
Mm-hmm.
Is that like that E thing? That's the sum.
That's the sum. That's the sum. Okay, so write those 2 formulas down, and then I'll where's your stuff? Get it out. You're gonna want to write this down.
Write some like that.
That's just how it's written. I don't know. It's an E. Whatever you want to do. But don't write it as an E like this. Sum is like, if you want to be really technical, that's what it looks like. But I don't have time for that. That's the summation thing. I don't care. Not enough. Ha. Okay. All right, let's deal with just the first formula first. The first formula looks easier than the second formula. It's not. Lies. Okay? All right, let me show you how this works. All right, this guy means the sum of all of your x's minus your x bar. What's the x bar mean? The average. Okay? What are x's? These are my data values. Okay? And what is n? The number of numbers that I have. Okay? Okay, example 2. How many numbers do we have?
1, 2, 3, 4, 5.
1, 2, 3, 4, 5. So n is
1, 4.
5. N minus 1 will be 4. Yes, true. But n is 5. Okay.
We're doing it right
Okay.
now. The sum.
Now, I need to know what x bar is. X bar is the sum of them divided by 5. Yeah? Does somebody want to find that number for me? What is x bar? If you add those up, I know you've done it already. Somewhere.
Let me find it.
It's on 3-1, like the first thing that we did, maybe.
23.8.
23.8?
Oh,
Is that the sum? No? No? No?
That's 30.74.
30.74?
We
We didn't do the mean of this ever?
No, we didn't.
Okay. All right. So x bar, the average of those numbers, of those 5 numbers, is 30.74. Good? Beautiful. Okay. All right. Here we go. All right. This table is used to assist you.
Wait, don't we need the sum?
What? No. Just wait. Just wait.
Oh,
This thing right here. This thing right here says,
so we're gonna use.
I need to add up all of my x's minus x bars squared, right? So the first thing, I'm going to put these in order. I'm going to start with 14.1. And you don't have to put these in order if you don't want to. But I'm going to start with 14.1. And the first thing I'm going to do is I'm going to take 14.1 and I'm going to subtract 30.74.
Why?
Okay? Because that's the procedure. That's what it says. X minus x bar.
But I thought you can't have a negative.
You just wait. Because we're going to square it. Okay? So 14 minus 30.74. I take x minus x bar. My first x is 14.1, and I'm subtracting the x bar. And that gives me a negative 15 point, I don't know,
Negative 16
Nope.
points.
16.64.
Yeah.
Okay? That's what x minus x bar is. But now I have to square it. And when you square it, it will only ever be positive, and that is positive.
276.8896.
Let's go 89. We'll go 2 decimal places. Okay? All right, so do you see what we did there? We took x minus x bar and we squared it for the first number. Okay? What I want to do for my formula is I want to sum all of them, which means I have to do it 5 times with each number, and then I have to sum them together. Okay, this is where the yucky part comes in. Okay? All right, my next number is 22.4. And then 23.1, and then 38.5, and then 55.6. Okay, we are doing the standard deviation, which means how is it deviating from average? I am trying to find out how far this number is away from average, right? That's why I'm subtracting them. How far is it away from the average, right? Okay, what? If I take 22.4 and I subtract the 30.74, what do you get?
Negative 8.34.
Negative 8.34. And then if you square it, square, positive, what?
69.56.
69.56. Okay. Then I go 23.1, subtract the average, which is 30.74. That is another negative number. 7.6, negative 7.64. And if I square that,
How many decimal places?
we'll go 2 for now.
58.3.
58.37. Okay. Next. 38.5 minus 30.74.
8 point.
That's positive. 8 point.
7.6. Or 7.
No, it's 7. You're right. 7.76. And then if I square it, positive.
60.22.
Thank you. Okay, then I do the last one. 55.6 minus 30.74.
24.86.
Okay, if I square it,
618.22.
perfect. There is all those numbers. Woo. I did all of my x minus x bars squared. Okay, now the formula says I take the sum of those. So what am I doing? Adding that right column here. All of those numbers. It's going to be like in the like 800s or 900s. Probably maybe 1,000. I don't know. If you add all those numbers together, we get the sum of all of them. The sum of all of the x minus x bars squared equals something like 1,000. Very good. 1083.05. Good? Okay. What?
1083.05.
That's the sum. Yep. Did anybody else do it and not get that?
831. Oh, I don't know what I'm doing. Hold on. Oh, I took like the full to the bubble. Like I didn't round. I took the full digit.
Oh, like each one of these?
Yeah.
And you added them together?
You want me to take?
No, that's fine. That's fine.
I missed a number.
1083.05? What did you get, Reese?
Hold on.
I don't know. I don't
Technically,
know.
I got
276 point. Whoop.
1107 point. Oh boy. Okay. Go out.
What did I do to you?
I got 1083.06 or 1083.05.
Mad at me since you switched into this.
Yeah, that's fine. Okay, we're close. We're so close. The formula says the square root of the sum of the x minus x bars squared. So the top number is
Square root of that.
1083.05. And then the bottom number is 4 because it's 5 minus 1, yeah?
Hold on.
So I'm going to take that number. I'm going to divide by 4 and I'm going to take the square root. And I got, I don't know, Josie, take your whole number.
I got 16.45.
Let's go more decimal places.
16.4548777.
Okay, there you go. Write that whole thing down. 16.4548777. That's my standard deviation. 4548777. Gross. That is disgusting. Imagine if you had 100 numbers. We had 5. And also imagine that those numbers are like in the thousands.
Thank goodness we're not doing that.
Okay, let's do this one now.
No, we want to be done.
No, this one's easy. This one's easy. We want to finish this page. Okay, let's talk. Let's talk real quick. This is the harder looking formula, but it's actually easier. What is n, by the way?
5.
5. So 5 goes here, 5 goes here, 5 goes here, right? My bottom number is 5 times 5 minus 1, which is
20.
20. Whoop. 5 times. All right. What does this thing say?
Which one?
The first one right here. What's the difference between this and this?
One, the square is squaring the whole sum, and one is.
Yeah, this one I'm squaring each one of my x's and then adding them together. This one I'm summing them first and then squaring them. Yeah? Okay. So this is actually very easy. Here are my x's. I'm missing a box. Yeah. Okay. 14.1 to 22.4, 23.1, 38.5, 55.6. Okay, if I square them.
198.81.
198.81. She's faster than me. 22.
501.
Okay. 501.76. Okay. 23.1 squared.
533.61.
Okay. 38.5 squared.
1,482.25.
Okay. 55.6.
3,091.36.
3091.36.
Yep.
Okay. All right. There is that. I'm going to scooch him over. This is the ugly formula, right? But it's not ugly. Okay. All right. I want the sum of all the x squareds. So I'm going to square my x's. I'm going to add my x squareds together. That's this column, the second column.
5807.79.
5807.79?
Yep.
5807.79. Okay. Now in this one, I want to take the sum of all the x's and square that. The sum of all my x's is these added together.
Surely we've done that before.
I don't know, maybe we have. Yeah, we did when you found the average.
153.7.
153.7. And then you square it?
23,623.69.
600 and what?
23.69.
Yep, 6 something.
23623.69.
Okay. 2, 3. Yep. Something like that. Woo! Okay.
We like reduce the
No, because this is trapped.
Okay, that's what I thought.
Yep. So if we take 5 times this minus this, that number, if you hit enter and then divide by 20, you get the square root of something. 5 times that. 5 times 5807.79.
270.763. Oh wait.
I got, oh, and then we got to divide by 20. And I got 270.763. And then we got to take the square root. Is 16.4548777. That is exactly the same. Which one do you like better?
I like them both.
The second one? I don't, yeah. I mean, I'd rather not do either one, but if I have to choose, I'd rather do the second one, even though it looks uglier. Yeah. But the second one is less columns and it's like less computations to do, right? It's faster.
Yeah, I don't like dealing with the negatives.
Yep. Yep. So there's that. Good? Yeah? Beautiful. Beautiful. Okay. We really have a little bit left, so we'll stop there. But here's what I want you to do for homework. Ready? You cannot do 1. Don't cross these off. You cannot do 2. You cannot do, I don't know. You cannot do 3.
Cannot do any.
Do we have anything that's nicer?
He's gonna find us. Sure.
Yeah, but I don't want you to have to do that many.
6, 7, and 22. We can have homework. We're gonna learn the rest.
All right, let's do this. I'm going to cut this down. Ready?
No.
You only have 1 homework problem. Do number 6, but only do the first 4 numbers. So pretend that the rest of the data set is not there. Okay?
Yeah.
So
First 4 numbers, you have to find the range, variance, and standard deviation. You don't know how to do variance yet. I mean, you do, but
just the range.
so do range and standard deviation using whichever formula you would like. Okay? Can you handle that? Okay, 4 numbers. That's all. Okay? Beautiful. Don't do number 7 because I'll show you how to do it with a calculator or a whatever. What? Variance is standard deviation squared. So it's basically what you get inside the square root before you take the square root. Yeah, we'll talk about that tomorrow though. Okay? All right, so do number 6. Range, standard deviation.
Do you think if I asked my mom really nicely, she'd bring me chocolate milk? Right there. Or no.
Wow. The formula is right here if you want it nicer.
The other way. I like the other way.
That one?
No, I like the other way.
You like the other one?
I like where you can see
I was talking about
Oh.
net worth.
Stop with
It's not my fault your net worth went up.
Okay, hold on. I'm going to pause the video. Goodbye.